As tranquil and calm as this ancient woodland appears, it is in fact bursting with life. Forests are some of the most biodiverse places on Earth, but the majority of species are not found above ground. They are instead hidden from view, inhabiting the soil beneath our feet. I'm not just talking about a handful of worms and beetles here. In just 1 teaspoon of this forest soil, there are thousands of millions of living organisms. Hidden below me is a different world, a whole ecosystem made up of intricately connected organisms, which make up the soil food web. This web is a complex community of organisms, each with its own niche, but all playing a vital role in the recycling of energy, carbon, and nutrients. In this 1 teaspoon of soil, there are over 1,000 million bacteria from 40,000 species, 20,000 species of fungi, and over 100 miles of fungal strands. This is an incredible amount of life. Bacteria and fungi are primary decomposers, and together with plants, they make up the base of the soil food web. They decompose dead plant and animal matter in order to ingest nitrogen, carbon compounds and other nutrients, which are held immobilized inside them. This remarkable process enables the transfer of energy, carbon and nutrients from dead organic matter into new life. Large bacterial populations attract predators such as protozoa. Ciliates, flagellates and amoeba are all types of protozoa, and between them help control the numbers of bacteria. Since protozoa do not need as much nitrogen as the bacteria provide them with, some is excreted into the soil in the form of ammonium. This compound is essential for healthy plant growth, since nitrogen is a key element in DNA. Protozoa also physically break up clumps of matter, creating air pockets and water channels, which is vital for both aeration of the soil and water retention. At each trophic level, organisms within the soil food web become larger and less populated. Even so, there may be as many as 1 million protozoa in this teaspoon of soil, all of which could become food for our next predator. Nematodes. In our teaspoon of soil, there may be several hundred of these bizarre-looking, non-segmented worms, of which there are 4 main groups free living in the soil. Each has their own dietary requirement. Some are omnivorous, some feed on bacteria and fungi, and some are predatory, feeding off of other smaller nematodes and protozoa. Only root-feeding nematodes are not free-living in the soil and are actually parasitic to plants. These guys have given nematodes a bad name. But in healthy soils, their population numbers are kept under control by predatory nematodes. Not only do nematodes control the balance between bacteria and fungi, they also release plant-available ammonium into the soil. Because just like the protozoa, their food contains more nitrogen than the nematodes require. Once again, they become food for higher level predators, including another major group in the soil food web. Arthropods make up 3/4 of the Earth's living organisms and include insects such as springtails, ants and beetles, crustaceans and arachnids. And it's organisms such as these that really shape and engineer the top layer of soil and detritus. Arthropods play several roles in the soil food web, but it's the shredding up of organic matter into smaller pieces that makes it easier for the fungi and bacteria to start decomposing. These impressive bugs not only have an important role in maintaining soil fertility, they also act as a taxi service for microorganisms that need a lift across town. The soil food web is made up of a multitude of different organisms and is far more complex than we can even comprehend. Organisms such as archaea and earthworms, gastropods and birds, all of these groups are part of this intricate web and are fundamental for a healthy, functioning soil. When soil is disturbed, and just one of these groups is compromised, the whole system becomes unbalanced. We can apply this knowledge to the plants we grow. From fields of crops to orchard trees, if we want to see improved health and bigger crop yields, we first need to nurture the soil food web back to health, and then we can let the soil organisms do the rest.